In this video, we're going to talk about the solubility of ionic compounds as a function of temperature. You can see from this table that the vast majority of ionic compounds increases in solubility as the temperature increases, meaning the warmer the solution is, the more solute can dissolve. And the reason for this is that the dissolving of ionic compounds is typically endothermic. So you can see here, we're just going to focus for the sake of this activity on a couple compounds, potassium nitrate right here and sodium nitrate right here as we work through these problems. So both of them increase in temperature in solubility as a function of temperature. And how you read this is the number of grams of solute that can dissolve in 100 grams of water to make a saturated solution at a given temperature. So for example, at 50 degrees Celsius, you can see that you can dissolve about 90 grams of potassium nitrate in 100 grams of water. So, and for sodium nitrate, at 10 degrees Celsius, you can dissolve about 80 grams of sodium nitrate. The higher up at a given temperature the compound is, the more can dissolve. So for a given compound, this is a line of saturation. These are all lines of saturation, meaning that they're at the line, they can't possibly dissolve any more solid at that temperature. If you can have less than that dissolved, and that would just be an unsaturated solution. But for the sake of this, we're just talking about saturated solutions which can't dissolve any more solute. So the first question I ask is how many grams of potassium nitrate can dissolve in 200 grams of water at 50 degrees Celsius? So what we would do is we would just use dimensional analysis. We know that we have 200 grams of water at 50 degrees Celsius. And if we look at KNO3 at 50 degrees Celsius, we said you can dissolve about 90 grams of potassium nitrate for every 100 grams of water. So you would say, since you have twice as much water, you can dissolve twice as much solute as you could in 100 grams of water. So that would be 180 grams of potassium nitrate that could dissolve. The second question that could be asked is how many grams of water would be required to dissolve 120 grams of sodium nitrate at 10 degrees Celsius. So again, using dimensional analysis, you start with what you're given. You have 120 grams of sodium nitrate. So now we look over at 10 degrees Celsius and we see that you can dissolve 80 grams of sodium nitrate at 10 degrees Celsius. So since for every 80 grams of sodium nitrate, you have 100 grams of water, you would need 150 grams of water to dissolve that much solute at 10 degrees Celsius. Now, a more challenging problem that you could be presented with would be to determine how much would precipitate as you cool a saturated solution. So this question asks, how many grams of potassium nitrate will precipitate when a saturated solution containing 200 grams of water at 50 degrees Celsius is cooled to 20 degrees Celsius? So now what we would do is we would look at how much could dissolve at each of those temperatures. And we see that at 50 degrees for potassium nitrate, again, you can dissolve 90 grams of potassium nitrate for every 100 grams of water. Since we have 200 grams of water here, that means you can dissolve 180 grams of potassium nitrate. This is what we did up here earlier. Now at 20 degrees Celsius, you can dissolve significantly less. You can see that you can only dissolve about 30 grams of potassium nitrate in 100 grams of water at that temperature. So, since you have 200 grams of water and only 30 grams of potassium nitrate can dissolve for every 100 grams of water, that means you could only have 60 grams of potassium nitrate at that temperature to be a saturated solution. So what we then do is look at the difference between what you can dissolve at the higher temperature, which is 180 grams, and what you can dissolve at the lower temperature, which is 60 grams, and you can see that 30 grams of potassium nitrate would precipitate. So bottom line, just use dimensional analysis to solve these problems, just like we've been doing all year.